So the question we have is, what option should you choose when merging commits into your main branch in GitHub? So the GitHub UI offers three options. You can create a merge commit, you can squash and merge, and you can rebase. So before we go into the details of exactly what we should do or shouldn't do, or what behavior you may want, let's look at what these actually do. So we have a scenario where we have a main branch with two commits, A and B. And then we have a scenario where we branched off of B, created commits C and E, and then meanwhile, we also had another commit to the main branch D. So we have a setup that looks like this. So if we're going to do a merge, what GitHub does is a three-way merge. It doesn't do a fast forward, it does a three-way merge where it takes the contents of C and E, leaves them as is, creates a new commit F by whoever hits that merge button, that's the committer, and creates that commit, and that commit has two parents, points to E and it points to D, and then the head of that main branch then points to commit F, and you can proceed forward. So another way, the second option, is squash. So what that does is it takes the contents of C and E, and then it puts them in a single commit authored by whoever pressed that commit button, and puts that on as a parent to D. The parent is now D, and then the main branch is pointing to C and E, and that's squash. The third option, when you do a rebase, takes the contents of C and E and essentially kind of replays those against the main branch. So it starts at D, and then it says, okay, C, replay that against D, and that's now C prime, and then the same thing with E, becomes E prime, parent of C prime. And then your main branch has a linear history, moves straight across, and your main head now points to E prime when you're all done merging. And then those contents, we'll talk about later, some of the metadata is changed in this. So the three things that we need to talk about are the contents of the commits, the commit metadata itself, and the commit history. So what happens to the history of that main branch when you merge things in. So going through commit contents. In a merge, what we have is the original contents are preserved. All of the contents, the commits are as is, unchanged, and the merge commit is separate from the original commit. So you end up with however many commits you have on that feature branch, plus one more commit that has two parents. And then main points to F. The head of main now points to F. In a squash, the contents of C and E are lost. So the end result is preserved, but the intermediate contents, let's say you change something in C and then change it again in E, the contents of C plus E will only contain the end result. They won't contain any of the intermediate results that are essentially squashed away into that single merge commit. So when we're looking at rebase, the original contents are preserved. There's some things that happen in case of merge conflicts that you end up having to fix. But in the case of no conflicts, the contents of C are preserved in C prime and then E and E prime. And then there's no merge commit. So things are moved over. So that's the contents. So we're going to talk about the metadata now. So in a merge for three-way that GitHub does, the original metadata is preserved. And then the merge commit, the metadata of that has information about the actual commit of F, doesn't reference C and E and all, it just says here's who pushed the button and the message for that particular merge commit. All the messages and the SHA hashes and the committer and author metadata are preserved on C and E. So if we squash, what happens to the metadata is the original metadata of C and E are lost. So the new merge commit from the merger, the author and the committer of that, plus the message and the SHA hash are new for that particular commit, whoever pushed the button. So that original metadata is lost. GitHub can add in some details into the actual commit message to say information about what intermediate commits were squashed together, but from a Git perspective, that's lost. Then we have rebase. So the original metadata is lost. There's a little bit of nuance. So the author and message are maintained, but the committer changes and the SHA hash changes. The commit SHA changes. So there's no merge commit, but all of the original metadata is kind of either lost or replayed. But the original commits, as Git looks at them, are gone. C and E do not exist in the main branch after this rebase merge. So that's metadata. Now we'll look at history. So in a merge three-way, we end up with a non-linear history. You'll see it branches at B, and you have two children, C and D, and then F has two parents now. It's a non-linear history. So when we look at that in GitHub's list of commits for the main branch, you'll see every single commit, A, B, C, D, E, F, but there's no indication that C and E were technically on a feature branch, and there's no indication that F has two parents. So you can't really tell what was on one. It looks like D, was on the main branch, which it was, and then it also looks like C and D were on the main branch, but they are, but they're not. They were on the feature branch that we talked about before. The second thing we need to think about for squash is it does have a linear history due to the nature of there's always going to be a single commit. So you'll always end up with something that looks like A, B, D, which is what we had on the main branch, and then we'll end up with a C plus E merged in there. For rebase, we end up with, again, a linear history, but we end up with commits that are present that look kind of like the commits that happened, but the metadata is slightly different. So what we'll end up with is A, B, D, so you can see the linear history that C and E were added in, and then you look at E has a different author than the committer in this case. So right here, whoever had C is the one who actually pushed the merge button to do this rebase. So for merge, squash, and rebase, the three things we're thinking about in terms of what we want and why we would choose something to squash or merge or rebase comes down to looking at our intermediate commits, our original metadata, and our linear history on the main branch. So the results of after the end of it. So for merge, we do preserve all our intermediate commits, we preserve all of our metadata, but we end up with a non-linear history, which when you look at it in the GitHub GUI, it can look confusing. It doesn't tell the whole story. When you have to look at things locally and dig into what the commits actually look like to see the parentage and be able to see the tree. For squash, there are no intermediate commits. The original metadata is lost, but there is always a linear history, and there's kind of a concept of an atomic commit per feature branch pull request merged into main branch. And then for rebase, we have intermediate commits are preserved. The original metadata is lost-ish, like we talked about before, but it is a linear history. You will go A, B, D, C, E. So you'll always be linear, but you don't end up with a single commit per pull request. You end up with however many commits were on that feature branch. So for our options, we got merge, we've got squash, we've got rebase. Ultimately, what you should do depends on the behavior you want and the environment that you're in. If you value those intermediate commits and you're actually reviewing those as part of your process for reviewing pull requests, and you're cleaning them up and you're maintaining their integrity, merge commits might be a really good option. If you're like, I want the equivalent of an atomic change in like a SaaS product that we deploy commits, and there's a very strong correlation between a commit was made and then that is one-to-one to a particular feature branch, which may be one-to-one to a fix or a feature, squash may be your thing. If you want to preserve that history, that linear history, but want to guarantee that linear history, but kind of preserve the intermediate contents, rebase is kind of in the middle there of kind of gets you a little bit of both worlds, a linear history, but you also preserve most of the contents and metadata of all of the intermediate commits in that branch. So ultimately, it really depends, but however it goes, go forth and merge and have a great time. Thanks.